Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atira binti Abu Bakar. My matric ID is MA18188. For experiment 5, Pelton Wheel Turbine, I will present chapter 1, which is the introduction. In 1870s, Lester Alan Pelton has invented a Pelton wheel, which is an impulse-type water turbine. It is also known as a hydraulic turbine, where the water jets impinge tangentially onto the mounted buckets. The tangential flow impulse turbine, where the pressure energy of water is converted into kinetic energy. It is to form a high-speed water jet, and the jet strikes the wheel tangentially and resulting it to rotate. The main source of power for Pelton wheel turbine is from the water. From the fixed head, we can estimate the velocity of the water, while from the diameter of the jet, we can determine the flow rate. This is figure 1.1, which shows the working principle of Pelton wheel turbine. Next, the problem statement of the experiment. We need to run an experiment by using Pelton wheel turbine to achieve designing a complete measurement technique and determining the performance and the efficiency of the turbine. The objective of this experiment is to design a complete measurement technique of the fluid flow and to determine the performance and the efficiency of Pelton wheel turbine at a different operation condition. The scopes that we need to run this experiment, we have 4 scopes, which is Pelton wheel turbine, hydraulic bench, data measurement and data acquisition, and also tachometer. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Nur Sufyan bin Sudin, and now I will continue for the chapter 2, which is the theory. The Pelton wheel turbine extract energy from the impulse of moving water. Water leaving those wheels typically still at high speed, carrying away much of the dynamic energy brought to the wheel. The Pelton wheel turbine is a tangential flow impulse turbine used for high head of water. The energy available at the inlet of the turbine is only kinetic energy. And this is the parts and sectional view of the Pelton wheel of the turbine. And this is the sectional view that consists of nozzle and flow regulation arrangement, runner and bucket, the casing, and also the braking jet. The turbine input power can be determined by measuring the turbine inlet pressure and flow rate of the water using the formula Q equal to rho GHQ, where the Q is the flow rate and P is the gauge pressure. The turbine output power can be calculated by using the force measured by the mechanical dynamometer radius and the dynamometer angular velocity omega using the formula Q equal to FRW. Then the torque can be calculated as the formula T equal to FR. The turbine efficiency can be calculated with the ratio of the turbine power output and the turbine required power input. The efficiency equal to work out over work in. Lastly, the turbine effectiveness can be determined by comparing the value of the efficiency of the experimental to the efficiency for the theoretical by using the formula W equal to FU. So I think that's all from me.
Assalamualaikum. My name is Samirul Ashraf bin Abdul Rahman, matric number MA18257. I will continue on chapter 3 of the experiment, which is method and procedure. So as you can see in the diagram, the water jets impinge tangentially on the fixed bucket. The power output provided by the Pelton turbine is calculated in this experiment using data from the pressure sensor, flow sensor and tachometer. The method is to produce torque by conducting or exerting force on the buckets of the Pelton wheel as it rotates. The fixed head can be used to measure water velocity, and the diameter of the jet can be used to calculate the flow rate. The wheel's diameter is usually 10 times of the jet's diameter. The Pelton turbine experiment is carried out with the help of several major components. The first one is the Pelton turbine. So the diagram shows are the main components of the Pelton turbine. So the first one is the spring balance, which is not compulsory to run our experiment. Second is the manometer, which to measure the inlet pressure of the water. And third is the nozzle adjustment. And fourth is the nozzle and the Pelton wheel, and last one is the brake adjustment. So second component is the hydraulic bench, which consists of the flow control valve. Second is the overflow, and third is the storage tank with pump, and fourth is the valve, and five is the measuring tank level, and the last one is the measuring tank. And the third component of the experiment is the data measurement and acquisition, and the last one is the tachometer. So the procedure of the experiment is started by making sure the connection, especially the pipe connection, is tightly connected with no leakage. And then the emergency button is released. After that, the water is added in the hydraulic bench to full tank to supply water during the experiment. And then the hydraulic bench is turned on and the valve is in vertical orientation. The spear controller is released to control or fix the volume flow rate and flow velocity. And then the main switch is turned on and the measuring tank level are measured after 60 seconds and the data are being recorded. So observe the flow sensor, pressure sensor and tachometer. Record and tabulate the data collected, such as rotational speed, moment of the shaft, power output, power input, and power efficiency. And then after experiment is done, switch off the valve and the main switch.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Salahuddin bin Mading, method number MA1824. And for the chapter 4, I will present about the result of this experiment. So for the result that we have been provided for week 8, that is the first one is the fully open constant at 0.2 bar and constant and at Q at 30.9 liter per minute. And this is the result that we have been given. And the second one is the power curve, pressure at 0.2 bar, Q equal to 11.75 liter per minute. So for the rotational speed versus moment of shaft, the graph show the relationship between rotational speed and moment of the shaft of the Pelton turbine. Based on the graph, we can see that the moment on the shaft indicator decrease when the rotational speed increase. The graph show a decrease linearly because of the negative gradient. Next is the power output and the versus rotational speed. The graph indicates the relationship between power output and rotational speed. Based on the graph, the power out from Pelton wheel will be decreased when the rotational speed increases. The next one is the efficiency versus rotational speed. The graph clearly stated that the relationship between the efficiency and rotational speed. Based on the graph, the efficiency will be decreased when the rotational speed of the Pelton will increase. And the last one is the power curve, that is to output to Q, that is 11.75 liter per minute, and also Q equal to 30.9 liter per minute. The last graph shows the relationship between power output and rotational speed with different flow rate of water jet. Based on the graph, the power output of Pelton wheel for the flow rate 30.9 liter per minute is higher compared than the flow rate at 18.75 liter per minute.
Assalamualaikum warahmatullahi wabarakatuh. My name is Safi Izzuddin bin Muhammad Nadri and my metric ID is MA18215. So we talk about the conclusion. This experiment was carried out with an acceptable level of accuracy. It was generally a success as the results obtained were results useful for the analysis of the properties of the machine. The best performance of the turbine can be known from the average speed of the turbine. For the turbine with the load, need higher average speed compared to turbine without load to get the best performance of the turbine. For the maximum power of the turbine produced show that with load in turbine can get higher power compared to the turbine without load. From the experiment results, it became possible for the real picture of the operational basics of the machine to be displayed in such a way that the characteristics of the turbine were visible in the graphical analysis is used. Other errors may have resulted from unseen leakage in the system and observational and computational errors. This experiment was, however, carried out with a great level of needs to reduce the occurrences of such errors.